What's going on, YouTube? Thanks for tuning in. Today on this 30-minute tutorial, I'm going to show you some of the more basic programming concepts to be aware of in Java. And at the end of the tutorial, I'm going to show you how to write a basic Java program. So stick around, we're going to have a lot of fun. Let's do it. Alright guys, so let's get into it. What is Java? So Java is a class-based object-oriented programming language, and it's a general purpose programming languages that allows application developers to write once and run anywhere. Java programs are typically compiled to bytecode that can run on any JVM regardless of the computer architecture. And the syntax is fairly similar to C and C++, but it has fewer low-level facilities, and it abstracts lower level operations like controlling memory and other things like controlling devices. It abstracts that away from the language, so it doesn't have those low level facilities. Now, you may be looking at this and you're wondering, like, what the heck is this? Well, this is just a small snapshot of many of the different uses and different places in which Java is used, right? So in terms of just server-side applications, a lot of server-side applications are written in Java to process millions of requests per day. Lots of big companies, from the Twitter, Facebook, to all different types of huge big tech companies, use Java in their everyday throughout their application. It's used in high-frequency trading application. So Java is huge in the financial services industries. So companies like Goldman Sachs, which I have here, Barclays and Citigroup, they use it to create data-intensive server-side applications, mostly without a front end, to serve API requests and process data that they're using, and a whole bunch of other things that a lot of financial services companies rely and depend on Java. So where else is it used? It's used in Android apps. Google has its own Android API, which is kind of similar to the JDK, but it's just Android classes that allow you to manipulate an Android device. So it has its whole development kit that you can, play with and use. So it's used to develop lots of Android applications and J2M applications as well. Applications that kind of work on different devices like Blackberries, what other devices, like Samsung devices, all these other types of devices, because Java's powers so many devices. In fact, it powers more than 3 billion devices. So a lot of applications, especially mobile applications, are written in Java. So web applications and e-commerce, it's used to write a lot of RESTful web services, using things like Spring MVC, Struts, Play. There's a bunch of frameworks written in Java that help you to write RESTful APIs and RESTful web services, as well as do things for e-commerce and other big web applications. Like I said and I alluded to earlier, lots of companies use Java. Big companies that you've heard of that are, applications that you use on a daily basis, they use Java, right? And then software tools, so like IDEs like Eclipse and IntelliJ, which are on the bottom right under this logo here, and NetBeans, they all are powered by Java and lend well to helping Java developers, because they're just sort of made conducive for Java and Java developers in general. It's used also in embedded devices. So you only need about 130 kilobytes to use Java on a smart card or sensor. In fact, it was originally designed for embedded devices, so it's coming back around for its original purpose, which is good, right? It's also used in big data. So Hadoop and other big data technologies use Java in one way or the other. So a lot of cloud technology, especially Apache technologies, like you'll see like Hadoop, Apache Storm, and Apache Spark. These big data technologies, they use Java. You can use other technologies like Mongo and C++ and other things with those technologies, but Java lends well to working with these technologies at a high level. It's also used in scientific applications, so natural language processing, and other things that are more specific to that. Java is great for that. And other industries heavily rely on Java, like the government, healthcare, insurance, education, a lot of these industries, when they're turning to application development, they use Java. For instance, in the government space, I lived in Washington, D.C., in the United States for a long time, and I worked as a software engineer for different companies that aided government agencies in developing their applications, their internal applications that they use. And most of them, if not almost all of them, use Java, some form of Java or the other. So, like I said, it's very big, and it's not going anywhere. The ecosystem is huge. And if you're thinking about it as a first programming language, it's an excellent choice. Um, so, what else do we need to know? All right, so I'm going to take you through how basic Java code is executed, right? So, here, what we have is sort of the flow of how a Java application goes from it's the code that you've written to code that the machine understands, right? So here what we see is, well, you take C++ for example. When you compile a C++ program, you generate an executable that runs on a target platform like Windows or Linux. For example, on a Windows platform, you generate a .exe file, right? But when you compile a Java program, right? When you compile a Java program, you use a JVM compiler or the Java C to generate a bytecode file with an extension of a .class. And these files can be run on any platform as long as that platform has a Java virtual machine installed, right? So basically, you write your Java file here. The Java compiler compiles it into a .class file, which is then used and processed by the virtual machine, the Java virtual machine, to process it into machine-readable code for your specific operating system. So if it's Windows, it'll process it into like its natural Windows language that Windows understands, and similarly for OS X and Linux as well. So a couple things to note here. I know this is kind of a convoluted diagram, but only a few things to note. Java C, that's the Java compiler. So Java C up here, right here in the gray, that's the Java compiler. And it compiles Java code or Java files, .java files into bytecode, which is .class files, right? And the JVM is the Java virtual machine, and it translates bytecode, which it receives from the .class files, and it processes that into the native machine code. So that native machine code is that natural language or language which your operating system understands. And it's different for different operating systems, right? So this is just a diagram of some other things. The JRE here, the JRE is the Java Runtime Environment, and it's software that's used to run Java applications, and it contains a JVM and other libraries. And the JDK, which contains all of this, is the Java Development Kit. That's what that acronym stands for. And it's software that's used to run and develop Java applications, and it contains the JRE along with compilers and debuggers and a couple other things. So we also have this concept of the just-in-time compiler, or the JIT compiler. So in the early days of the Java, the JVM would compile bytecode into machine code all at once. Now Java has a JIT compiler which compiles a lot of the bytecode dynamically when it's needed. And an advantage of this is that the JIT has access to dynamic runtime information, so it can make optimizations based on that, right? So in essence, we have the JIT, the just-in-time compiler. So in order to improve performance, the JIT compilers interact with the JVM at runtime and compile suitable bytecode sequences into native machine code, right? So while using the JIT compiler, hardware is able to execute the native code as compared to having the JVM interpret the same sequence of bytecode repeatedly over and over and over, and incurring high overhead for translation processes. So what does that mean? That just means that before everything is processed into that native machine code, we want to put it through the just-in-time compiler. So it's basically the same diagram, but you now have the just-in-time compiler over here on the far right. Before it translates it to native code, we want to make sure we do things for performance. So basically what the JIT compiler really does is it gives you certain performance gains in execution speed. So the JIT compiler is able to perform simple optimization tasks while compiling a series of bytecode to native machine language, right? So it does everything from data analysis to reduction of memory access to register allocation. It does translation of stack operations to register operations, and it also does elimination of common sub-expressions. So basically what the JIT compiler does in a nutshell is it makes certain performance enhancements at runtime. And that's pretty much all you need to know on a basic level. What you should commit to memory these are the data types, and the data types available in most programming languages, not just Java. So you have your byte, your short, your int, your long, your float, your double, your char, your boolean, and these all have different sizes and different ranges. And you should know these ranges, especially for the more minute data types like byte, short, int. You should know that a byte is about 8 bits or 1 byte, and it ranges from minus 2 to the 7th power to positive 2 to the 7th power minus 1, which is minus 128 to 127. Should know that, boom, off the top of your head. A short, 2 bytes, 16 bits, and it ranges from minus 2 to the 15 to positive 2 to the 15 minus 1, which is about minus 32,768 to positive 32,767. And likewise for an int, it has 4 bytes or 32 bits. So minus 2 to the 31st power to 2 to the 31st power. That's minus 2,147,483,648 to positive 2,147,483,647. You don't need to know these exact numbers, but you need to know that an int can store anything from about minus 2.1 billion to positive 2.1 billion. So if you're trying to store a number that's bigger than that, which I rarely doubt that you will, then you need to use a bigger data type like a long, which it's double that of an int, and it's too large to remember, so don't even bother. You just need to know the basic data types like byte, short, int, those type of things, and their values and how many bits and bytes are in each. So try and commit as much as this to memory, at least the first 3 to memory. Like I said, you don't have to know the exact numbers, but I mean, for bytes, and it's a pretty small number. It's minus 128 to positive 127. You should know that. It's because there's less room for error using a byte. Same with a short. You should know it's about 32.7 thousand. But for an int, you don't need to remember this long number. It's about 2.1 billion, minus 2.1 billion, and positive 2.1 billion. Also to note, in Java, strings are immutable. So unlike other programming languages like JavaScript and other languages, once you create a string, it's immutable. So once strings are created, that means they can't be modified. So here, hello and hi are 2 different objects. The variable bar was reassigned to the object hi. And advantages of this include like certain security advantages, like strings are often used as identifiers, for example, right? So they're used as identifiers in like a hash map. And a hash map is just a data structure that stores key value pairs, if you're not familiar with hash maps. Or a path to a file. So if you modify them, then the key would change, and the users of this key, they need to stay updated. So this would pose like a security threat. So imagine if some user modified the string identifier and now other users can't use it, right? And also helps with thread safety as well. So since they can't be modified, they can be shared between threads freely without any need to synchronize. Another thing to note is access modifiers. So we have different access modifiers, which are basically each variable in a class are given a specific access modifier. And if none is given, a default specifier is used. So public is visible to the world. Protected is visible to classes within the same package or subclass. So you see that here where it's visible. Default, it's only visible to, which is no modifier specified. It's only visible to your class and your package. And private is only visible to that class, right? So here's just a chart of that. And here's also a diagram of that. So you see here, private class only, default class in that package. Protected, you have your class, package, and your subclass. And public, all classes are able to view that. So yeah, that's just some basic things to note about Java. What I'm going to do here is I'm going to open Eclipse and I'm going to take you through the anatomy of a basic Java application. A small one, a basic, hello world application where you write out your print statements and other things. So yeah, join me for that, and we'll figure out how Java works when you're actually coding it and actually in your IDE. All right, guys. So I'm in my Eclipse IDE, and I'm in my algorithms project. And in that project, I have a package named examples. I'm going to go ahead and right click and go to new and then go to class. And I'm going to create a new class called Java program. Right. And I'm going to go ahead and click public static main because that's the method stub that I want to include. And I'm going to click finish. And you're seeing quite a bit. You actually don't need this. But what is it that we're looking at here? So I'm going to take you through the basic anatomy of a Java program, step by step, just so you know what everything is. So the first line you have here is your package, which this class is held in. And you can see it's in package examples. In fact, we literally just did that. We just right clicked and we made a new class in that examples package. So that's literally what you're seeing, right? And under that, you can include all your imports. And basically import statements, they're used for accessing special features of the language or special features of Java that are not a part of the core language. So things that I can't just type here in my class or in my main method and just use. I have to specifically import them. So one of those is like java.util. There's a bunch of these classes, these helper classes. So, and in fact, you can start to see them when you're about to type them in autocomplete. So you have like the lang package, the IO used for input and outputs. You have a bunch. You have security, you have text, SQL for connecting to databases, streams, regex, all that good stuff. I'm going to import a random one lang. And you can just do a mass import of importing like basically everything under lang by using this wildcard here, this asterisk. And that'll import everything under lang instead of importing like a specific class, right? All right, so what's on line 4? You have your public keyword. Remember, we talked about access modifiers. And then you have your class keyword. And just so you know, everything here in purple in your IDE and Eclipse and other IDEs, these are reserved keywords. There's a bunch of them. There's not too many to know, but there's a bunch of reserved keywords, and class is one of them. So when you're declaring a class, you have to specifically label the class with the class keyword first and then the name of your class, followed by your opening and closing curly braces, right? And Java has a bunch of classes. There's many different types of classes, but a class with a main method is called a program. So what we're looking at right now is a Java program, right? So the main method is where the execution starts and stops. And even though the main method can ask other classes and other objects and other methods or parts of the Java language to help, the overall execution of your program begins and ends in the main method. And right here is just the general structure. And I've already started to talk about some of this. So what is a static word? I mean, I talked about the public access modifier, so we won't go through that too much. But what is a static keyword? Basically, the keyword in static means that it's used for memory management, just to put it, in a layman's sense. And it can be used with variables, methods, blocks, nested classes. And it's a keyword which is used to share like the same variables or method of a given class. So a given class will create these variables or methods and whatnot, and they can be shared amongst other classes or elsewhere in your Java program, just outside of that class. So basically, static is used for a constant variable or method that is the same for every instance of a class. That's basically what static is used for. And now start to make sense as you start to use these keywords more in Java, right? So the next thing we're going to talk about is the return type. What is a return type? So when you create methods in Java, your method is going to do some sort of work. It's going to, execute some sort of steps and return some result, or just execute some sort of steps without returning anything. And when it doesn't return anything, you will label it as a void return type, because it's void. Like the word void means in English, it's empty, it's null, it's like, destitute essentially. It's nothing, it's nothingness. So here we're not returning anything. We're going to do some work, which can be printing out something or calculating something, but we're not returning anything. But we could return one of the basic data types, or we could return objects from methods. So just be aware of that. The main method has no return type, so it's always going to be void, right? And then here in the parentheses, where it gets a little bit interesting, these are blah, 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 command line arguments, almost like a tongue twister. And command line arguments basically allow you to specify what sort of configuration information that you want to pass to the application when it's launched. So they're specified after your class name and between the parentheses in your IDE. But if you're running this like on the command line itself, you would do something like, let's say you had a class called sort, and just pretend like these lines that I'm about to type on the bottom this is not valid Java code, but this is something that you would type on a command line. So let's say you say Java, and then you have a class named sort, which takes some arguments like a file, and it sorts the names in the file, right? So we have file.txt. So basically, when you, when the application is launched and the runtime system passes the command line arguments to the application's main method via these, it's an array of strings. And this would be one of the strings in this array, basically. So your command line arguments are basically anything that you would pass to a file to do some sort of work or what have you. And these are the arguments that would be passed under the hood if you're using the command line. But here you don't have to worry about command line arguments. That's just something like that you, again, use on the command line. But if you did want to pass it some sort of like text file or something, that's where it would live. It would live in these this string. This is a string array. This is an array of strings here, and the array is called args. So you can loop over args and print out all of the command line arguments if you have them. The next thing we're going to talk about are variables. And what are variables? Variables are basically a symbol or name that stands for some sort of value. And we declare variables by asking the computer to set aside a place in memory where we can store a particular piece of information. So whenever you use the name of a variable in your code, the program refers to the value stored at that memory location. So in Java, variables are typed. They're not like, if you're familiar with other dynamic programming languages like JavaScript or Python, these variables are not typed there. So what does that mean? That means that it can only hold one type of data. Whereas in JavaScript or something like that, you can like say foo, something like foo, and then in foo you can store anything. You can store a string, or you can store like a number, and that would be valid in JavaScript. But here in Java, what you do is you declare the type first, and the type would be one of those basic data types that we talked about earlier on in the tutorial. It could also be like an object as well, but for now we're going to stick to the basic data types. So it'd be something like int var, and it equals 10. And remember, for this data type int, it goes from minus 2.1 billion to positive 2.1 billion. So basically, numbers that fit in that range can be stored in this variable var, right? And that's gonna bring me to statements. What are statements? Basically, statements represent an action to be carried out, and statements in Java are like sentences in English. Sentences have a basic structure in English. You have your subject, your predicate, and then you have your punctuation that you include, and you have a period. So you terminate statements in Java with a semicolon. As you can see here, we have this semicolon. You have the semicolon, basically, which terminates that statement there on line 7. So basic types of statements in Java, you can have print statements, for outputting information to the screen, to an output file, or, and they basically, we haven't covered that yet, but just know that that's an option. That's something that you can do. And if you want to output something to the screen, you can just do something like system dot out dot print. You can use either, what is this? You can use print, or you can use print. This is a valid function in Java. Print, you can say hello world. Let's be very cliche. You can say print, or you can say print ln. Now, what's the difference between print and print ln? And I'll go through it really quick. So print, that just prints things on the same line, right? Without moving the cursor to the next line. Print will print on a line and move the cursor to the next line. So if I had multiple print statements, like, let me see, if I had just multiple statements like that, let me go ahead and copy this line. I'm going to show you really quick. So all of this for a print, if you're using print, these are all going to print on the same line. So I'm going to run that, and you're going to see. It's going to make sense. Okay. Yeah. There you go. They're all on the same line. So I just wanted to show you that. But if you went and added the ln, they would all be on different lines. It will carry over to the next line, to the next line, to the next line, to the next line, and to the next line. Right? So boom, run that. And yeah, they're all on different lines. So that's the basic difference between print and println. And we also have assignments, right? So we did an assignment here. We assigned 10 to var here. Similarly, you can just declare other variable types, like float, fl equals to 9.0. 9 sorry, not float. We could say double. Let's use double, and use db. Or floats, I think they have to have the f at the end. That's why I was getting an error. Yep, that's how you have to have it. You have to have, so that's basically a float. If you want to have a float, or declare a float, you can't just use decimals. You have to add the f at the end. So that's the, floats. All right. So we covered what? Assignments. We covered variable declarations. import statements. We covered the main method. Yeah, this is basically a basic Java program, and um, you know, that's how you use Java, on a very basic level. There's lots of other things you can do. There's conditionals, there's, for loops, while loops, there's all types of things that you can use to do your work and execute certain tasks in Java. I just wanted you to be able to do the um, cliche print statement, printing out hello world, hello Mingtech Media. Subscribers. Thanks for watching. So we can print that, and again, if you want to, experiment with something else or clear a console, you can right click and clear. And I'll clear everything down here, and then you can go ahead and run this again. And then, yeah, there you go. Hello, Mingtech Media subscribers. Thanks for watching. So this is the basic anatomy of a Java program. I don't want you to get bogged down with too much technicalities and too many intricacies. So I really wanted to keep this brief and very, very simple, because we might have some people who are migrating from another language or people who are learning programming new altogether. So I wanted to include enough information for both sets of people, or both sets of viewers. So I hope this was, informative, and you were able to grab a lot about the Java programming language and basic Java programming concepts from this tutorial. I'll end this by saying, please like, comment, and subscribe so I can continue to put out more content like this. When I know I'm helping people, it just motivates me to put out more content. And if you have any other suggestion videos for things that you would want to see, please let me know as well. And like always, I'm hoping I was able to help you, because that's what these videos are for. And I'll say thank you, and you have a great day.